Hello students, in our last lecture we have already started with the topic called as higher order derivatives, or we can say second order derivative, because we have our syllabus restricted only up to second order derivative. So in this lecture we will be taking some of the examples based on higher order derivatives. So students, I welcome you all. My name is Pankaj Lade. Let's begin with some of the examples of higher order derivatives. Now look at the question that I have written on the board. The question that is written is x is equal to a cos cube theta, y is equal to a sin cube theta, and is asking us to find d2y by dx square. That means you want to get the second order derivative. I hope you remember that order means how many times you are differentiating a particular function. Now did you notice that x and y, both of them are depending on a variable theta, and this we have already seen in something called as a parametric differentiation. Make sure that you have watched the previous lectures of parametric differentiation to know the concept more in detail. Now since this is parametric differentiation, the first thing I should be getting is dy by dx. Only when I get dy by dx, I can proceed further to get d square y by dx square, isn't it? So the second order derivative can be obtained only once we have got the first order derivative. So let's first of all get dy by dx, isn't it? Now since it is parametric differentiation, I hope you know the formula. Dy by dx is given by dy upon d theta whole divided by dx upon d theta, isn't it? This is the formula for parametric differentiation. Since theta is a variable, both x and y will be differentiated with respect to the variable theta. Now if you observe here dy by d theta, it simply means d by d theta of your y. So what is y given to us? What is y given to us, students? Y is a into sine cube theta, isn't it? And likewise, if I go in the denominator where I see d by d theta and then there is x, what is x given to us? X is given to us as a cos cube theta. So again and again I am telling that your basic concepts of derivatives must be very strong. You should definitely have watched all my previous lectures. Please go and watch them again. If you have any doubts, make sure that you clear all your basic concepts, your formulas, the composite functions, everything very thoroughly. Only then you will be able to understand these solutions. So now let's differentiate this a into sine cube theta. So you can easily understand that a is a constant, so it goes outside the derivative. Then you see sine cube theta. Sine cube theta is like x cube, isn't it? This is composite function, so you need to make use of the chain rule. So sine cube theta is like x cube, its derivative is 3x square. So I'll write 3, then I should be writing x square, but it is not x, it is sine theta, so I should be writing sine square theta. And since it is not x, I will again differentiate whatever is present in place of x. So this was like x cube. So what is in place of x? It is sine theta. So again I should be getting the derivative of sine theta, which is cos theta. So that's your numerator, the derivative of the numerator. Let's now go to the denominator, and again if you observe, there is a, which is a constant, goes outside. Then again you have cos cube theta. Again it is a composite function. It looks like x cube. So see, again and again I am using the concept of composite function. So make sure that you have already watched my lectures on composite function. I have taken all the questions in too much detail about composite function and the example. So make sure that you go and watch all of my previous videos. So now cos cube theta, the derivative is going to become 3 cos square theta, and again the derivative of cos theta, which is minus sine theta. So I hope you have understood the derivatives concept here. So obviously a and a cancels from the numerator and the denominator. The 3 and 3 also cancels from the numerator and the denominator. One of the sine theta will get cancelled and one of the cos cos theta will get cancelled. So ultimately what things are left? Have you noticed the negative sign over here? The negative sign is also present, isn't it? So make sure that you do not miss that negative sign. You have to be on the spot while writing all the terms. So the negative sign, so you write the negative sign over here, and you see there is a sin theta left in the numerator and a cos theta left in the denominator. That gives me tan theta. So students, what you have got dy by dx as? Your answer of dy by dx came minus of tan theta. Now again, what was your question? You needed to find d2y by dx square, or you can say second order derivative, d square y by dx square. That means once you get dy by dx, you should differentiate both hand sides with respect to x. What is dy by dx that you have got? You have got the answer as minus of tan theta. This is very tricky and very important concept. I want everyone to pay proper attention at this particular step. So keep all the things aside and just focus on this step, because this is the most important step of the entire solution. So I've got dy by dx as minus of tan theta, and I want to go further and differentiate this again both sides with respect to x, because only then I will be getting d square y by dx square. So let's do it. Let's differentiate both sides with respect to x. So I get d by dx of dy by dx. So d by dx of minus of tan theta. Now that's very important, people. Here d by dx of dy by dx, obviously it becomes d square y by dx square, or you can say d2y by dx square. But now be very careful on the right hand side. Very careful. Observe the right hand side. There is tan theta, and you want to differentiate with respect to x. Now many of the students I have seen, they start assuming that I want to differentiate with respect to x, but there is tan theta. Some of them directly write the answer as x square theta and they end up the solution. Some of them imagine it like it's a constant term and they write the answer as 0. These are all wrong answers. You need to understand what is x, what is y, what is theta. Do you know that x and y have some relation with theta? They are both depending on theta. That means x and y, since they both depend on theta, theta also has some relation with x and y back, isn't it? So theta is also depending on the values of x and y. So there is an interdependency between x, y with theta and theta with back to x and y. That means as x and y are functions of theta, so is theta a function of x and y. It is not a constant. That means here theta is some function of x. I am not interested what that function is. It can be any function, but I should be aware that theta is a function of x. So now differentiate tan theta as you have differentiated tan x. What could be derivative of tan x? It is sec square x. So what could be derivative of tan theta? It will be sec square theta. There is a negative sign. Make sure that you take care of the negative sign. So I'm going to write the answer as minus the derivative of tan theta. Theta is not a constant. It has something in x. So the differentiation will come sec square theta, and the most important term, since this is a term of theta, this d theta by dx term is going to appear over here. This is the very important term. Try and understand this like this. Theta is a function of x, something in x. I don't know what it is. So it can be written as tan u. Do you remember d by dx of tan u? This was taken in composite function. So again I am telling, make sure you have already watched all my videos on derivatives where I have taken composite function, implicit function, logarithmic differentiation, and all important concepts of derivatives. So derivative of tan u, it becomes sec square u, but since it is u, you you have to again differentiate u with respect to x, and you write du by dx. Here u is replaced with theta, so I'll be writing d theta by dx. So that d theta by dx is very important term. Now we have also seen inverse differentiation, isn't it? Derivatives of inverse function. So d theta by dx can also be written as 1 upon dx by d theta. That's very important, students. We have seen this concept in our previous lectures, so make sure that you are already watching all of my videos. So 1 upon dx upon d theta. So d theta by dx became 1 upon dx by d theta. Again, very important to note down over here that d theta has not changed its position. It is not d theta separate and dx separate. These are not two separate quantities and they are not in ratio of each other. So d theta by dx is actually d by dx of theta, but we have seen all these things in theorems where inverse trigonometric functions are differentiated in this manner. 1 upon dx upon d theta is going to happen. Now let's go back and find out the answer of dx by d theta. Do you know that dx by d theta was your denominator, isn't it? In your original, when you started the solution, the original step contained dx by d theta and the answer was here. See, this is your answer of dx by d theta. So I'm going to directly use the answer in this particular step. So let's write the answer directly. So I get here minus of, also can I write sec square theta as 1 upon cos square theta? I am simply saving my steps. So sec square theta can be written as 1 upon cos square theta. Then I have 1 upon, what is dx by d theta answer? This entire big statement, it is there the answer of dx by d theta. So I'm going to take this term and put up over here. So my answer comes, there is a negative sign, let's put up a bracket, there is a negative sign present in this step. Then there is 3 which is a constant, a which is a constant, then there is a cos square theta and a sin theta, isn't it? So now if you take all these terms, negative negative becomes positive, so that goes out from there, or you can say they can be cancelled. 3a is a constant, can be kept in the denominator, and then there is cos square, and cos square becomes cos raised to 4 and sin theta. So my final answer is going to look like this: 1 upon 3a cos raised to 4 theta into sin theta. So that's the answer of d2y by dx square. Now students, I hope you have understood this solution very properly. Make sure that you note down this entire solution very properly somewhere in your notebook so that you can have it for your reference. So students, we will be making one more video to understand this concept of higher order derivatives in more detail. Make sure that you watch the other video also to understand the concepts. I thank you all for watching this video. Make sure that you like these videos, share them as much as possible with your friends. Thank you so much for watching. You all have a great day ahead.